Hey, I'm Greg. I've been involved in the stable process since the beginning, the security team of the kernel. I'm a developer and maintainer of this. I've been doing this for a long time, primarily focused on drivers. But I want to talk about Rust. I've also, since I'm part of the security team, I have seen, I think, every single security bug in the past 25 years in the kernel. We do CVEs now in the kernel, and we're running about 13 CVEs a day. I'm going to give a talk about that later. Don't worry, it's the same as the other operating systems. But let's talk about Rust. Why is Rust good for that? But let's also talk about C, because we have a lot of C in the kernel, and that's not going away. We're going to do that. So here's a nice fun chart. I give it some conferences. This one shouldn't need it that much. A lot of, when I go to the cloud people, they're like, what is Linux? Well, Linux is what everything runs on the cloud. Same thing with AI. Linux actually runs the world. And that's important. Linux is one of the most important operating systems out there, most important software projects, and let's still make sure this project continues. It's a big community. Last year we had almost 5,000 developers, 350 different companies. Every release we have about 200 to 250 brand new developers. We have a problem of too many developers. It's a good problem to have. We're not complaining, but we do a lot of work. We have a lot of stuff. That's our rate of change for last year as well. It's still the largest software project out there for our rate of change, and it hasn't slowed down in the past 10 years. It's incredibly fast. Like Lena says, our project is not stopping because the world hasn't stopped. We still have new hardware, we still have new usage models, and we also go back and refactor old stuff. Famously, if you've ever been involved in a project for a long period of time, you look at some code and you're like, who wrote this stuff? It's horrible. You dig back through history and you're like, oh, that was me. That happens a lot. We do a new release every 8 to 9 weeks. We've been doing that for 15, 20 years now, like clockwork. A good engineering project, like the Linux kernel, can be relied on. That's a very, very good thing to do. I like seeing that in other software projects as well. That's our rate of change. All's good. How we do this, I gave a whole long talk at a recent podcast. Just search that, and you can see 90 minutes about how we do this type of stuff if you're interested. And also, a lot of people don't realize Linux, it actually runs the world. Android, 4 billion Linux devices out there. Almost everything else is a rounding error. Servers, Chromebooks, the #1 Linux on the desktop for the past 10 years. Chromebooks, laptops, all are Linux. Linux on a desktop is here. Nobody realizes it. All Wi-Fi devices, all Wi-Fi modems. Until Apple recently, there was a version of Linux in all iPhones in that modem. Didn't realize that, but Apple relies on Linux. TVs have been all Linux, washing machines, air traffic control in Europe and other places. My favorite, there's a automatic cow milking machine, runs Linux. All the electric chargers in the world run Linux, things like that. So let's talk about code, the code behind it. This is a Keynote, so let's get technical. This is some C code, real C code in the kernel. And it's buggy. Turns out this is in the Bluetooth stack. Turns out somebody reported, hey, we can crash the kernel in here. Let one of our interns, we have a very good intern program at Linux Foundation that Shua Khan runs, let them on this, and they fixed it. And here's the fix. Maybe. Turns out we were not actually looking at what P was doing. If P would return null, the kernel would crash because we would dereference later. So we fixed it up by saying error, go to unlock, everything is good. 3-line change, intern wrote it, got assigned to CVE. They got to add it to their resume, all was good. Later on, they actually got a job because they can fix a bug, a security bug in Linux kernel. Our internship process is really good. So, very common bug fix, very common thing. This is C code. We see this happening all the time. And unlock goes down there. You got to remember to jump to unlock and clean things up. So C, when you're reviewing C code, you got to remember and keep a mental state of everything that's going on. Is the person checking to see the error value is there before they dereference it? Did they actually unwind things properly? And that's a lot of state to keep in your mind. Reviewers have to keep a lot of this going on. And here's another bug that was fixed recently. The error check was done properly, but we jumped to the wrong place. Instead of returning error, we actually needed to jump somewhere else to clean something else. Again, another CVE. That's hard. That's hard to keep in your mind and mentally state. So in C, in new versions of C, there's something called auto-unwinding, like automatic variables. And we finally took advantage of that in the kernel. And here's an example of that. So the red code is stuff we've removed, green is what we've added. So instead of keeping the state, we can just say guard the code below this, And then when it returns, it'll clean things up properly for us. This is good. This is good stuff in the kernel. I don't recommend going and cleaning up the kernel with this because it gets annoying people, but all new code in the kernel should be written like this so that we automatically do this and the compiler catches this for us. When I see this as a maintainer, I'm like, great, I don't have to worry about the error handling. It's all done for us automatically. Here's another example of this when we allocate memory. We allocate memory, and then it's cleaned up automatically for us when we're done. But sometimes we need to hold on to it so we can hold on to it. But this is good, making our size of our code smaller and work more automatically. This is a good thing. And C-scoped locks and allocators, we got a whole document in the kernel about this, if you're kind of interested. Makes the coding simpler, reviewing is easier. Our main bottleneck in the kernel is reviewers. AI is doing this and turning all you into reviewers if you do that. Reviewing is hard. Less bugs, more fun. That's the whole goal here. Make things more fun to work on. So let's look at this old C code. If we were to write this in Rust, what would this look like? Almost automatically the same thing. Except the first line, you got a little question mark at the end there. Rust is kind of fun with some weird things like that. But that question mark says, I am checking the return value of this, and if I get an error, I will exit out. And if you don't put that question mark in there, the compiler will complain and not build. And that's the key. Rust lets us express things in code that if the code is wrong, it just won't compile. So if me as a maintainer gets a patch from you and written in Rust and it compiles properly, you did the logic right. And that's good. That saves me reviewing time and it makes things easier. Same thing with locks. Rust, when you put a lock on something, you guard the data you're trying to lock inside the lock. And the only way you can actually get access to that data is by grabbing the lock. The compiler will not let you do it without that. And by doing that, when you're done with the data, it'll free the lock. That, again, is enforcing a pattern in the compiler, in the code itself, making it easier for us to do stuff. Between those two things, checking error values and handling a lock properly and three things, resource stuff, that I'm guessing, I say, is about 60% of all the security bugs in the kernel. Somebody told me I was wrong, and they think that's about 80%. If we do those simple things, so many security bugs just instantly go away. And that'd be great. And that's why I'm excited about Rust. It makes it easier for us to write code properly. Rust can fix these security bugs ahead of time, before anybody ever sees them, before even the reviewer has to maintain them. I, as a reviewer, have less state to have to keep in my mind. And that's good. It enforces the things we're really curious about, we like. Makes it simpler, smaller amount of code. Reviewing is easier, less bugs. We can have more fun. Because, again, we have lots and lots of developers. We have very few maintainers. Maintainers' jobs is hard. If I don't have to keep that state in my mind, I don't need to. It's good. And so Rust can do all this fun types of stuff. Enforce the validation of untrusted data. And that's a very important thing. Microsoft fellow famously said, all input is evil. If you take nothing away, remember that. All input in the software is evil. And you have to test that. You have to check it. Rust can enforce this. There's some really cool patches out there that I've been working with that we can mark the data coming into the kernel as untrusted. And the only way you can access that data in the kernel logically is by going to a validator. So me as a maintainer, I can go, where's the validator for this? Great, I can focus on that one part. As a reviewer, that's wonderful. Handle all the memory lifetime rules, locking rules, error handling, and type safety. Type safety is very important as that. But Rust is not a silver bullet. It's not going to just save all our bugs. Everybody says it's memory safe. Well, memory safe is interesting. Memory safe means if you do something wrong, your code will just crash, which in the kernel is not good. That's still CVE. So here's some code that you can write, C code, crash wonderfully. It's a logic error. Rust, this is Rust code. If you access this thing, I'm going to run off the end of an array. Rust will check that, catch that at runtime, and go, you know what was going on, crash, you're gone. And that's good. At least we're crashing. We're not accessing memory in an illegal way that would allow you to have a security vulnerability. Rebooting the machine is still a vulnerability. It's still a denial of service, but it's not a bad one. So you can still do same bad things. Rust is not a silver bullet. So just please take that away. Memory safety doesn't mean there's never any memory errors. Just means you're going to crash, and that's fine. Rust is in the kernel today. Again, we have 35 million lines of C code in the kernel. You only run on your laptop about 2 million lines, 2.5 million lines. A server's very simple, 1.5 million lines of code. You need a network controller, a storage controller, maybe a GPU driver. Phones are like 4.5 to 5 million lines of code of the kernel. Phones are SoCs are the most complex beasts out there. And we have 65,000 lines of code in Rust in the kernel today. We have bindings, which is the intersection between the C code and the Rust code in the kernel for platform drivers, PCI drivers, MISC device drivers, PHY drivers for network cards. We have I2C on the mailing list. We have LEDs being reviewed. DebugFS is in there. All the APIs to talk to locking and to do memory management type of stuff in there. You can write real code in the kernel in Rust today. In fact, we have some little bits of code. When your kernel crashes, it'll show a QR code on the screen. You can scan that and get the kernel dump. That code's written in Rust. Famously, this code that handles the crashing of the kernel was passed a buffer and a size of the buffer. The Rust code forgot to check the size of the buffer. So when the kernel is crashing, you got a buffer, it would actually write over the buffer and go up past the end and crash again. So we fixed that up. But Rust, again, it's not a silver bullet, but does things very nicely. You can write platform drivers. We're getting some basic drivers. I want to call out Red Hat is doing an amazing job writing the next GPU driver for NVIDIA. ARM has a GPU driver written in Rust. We're seeing some SoC drivers from Qualcomm, they're coming in Rust. And Binder. Binder is an Android. It's the IPC that Android relies on and does the work. The Android developers at Google have done an amazing job in the kernel. They're core Rust contributors, and they've done really, really good work. And now that code is in Linux, and it'll soon be in devices, and Rust in the kernel in Linux will be relied on, and that's a good thing. So it's there today. I encourage people to play with it if you want to. It's kind of fun. A friend of mine many years ago said, hey, you should look at Rust. It makes programming fun again. I was like, yeah, I'll worry about that later. And it's true. I took it up about 2 years ago. I'm not a good Rust developer, but it's calm. It makes things, if the code compiles, it actually works. It's turning programming fun again, which is nice. This is why we do this type of stuff, right? To make things fun. Change, you guys have seen people complaining about Rust. Change is hard. But if we don't change, we will not succeed because the world keeps changing. And that's okay. Not everybody has to convert. We're not going to write new existing code today in the kernel. I'm not going to rewrite it in Rust, but new stuff can do it. We get offer the opportunity to do this stuff, and that's good. If we don't change, we won't succeed. But Rust also lets us reevaluate the C code, and that's good. Our APIs sometimes are really hard to use. Like I talked in the beginning, you look at code that's been there like, what? Who wrote this? This is horrible. Oh, I wrote this. Well, you learn over time that your APIs were wrong. Rust lets us revisit that and rewrite the APIs. If Rust were to disappear today, our C code is better for it, because they've made us reevaluate a number of our APIs and rewrite things, fix things up, make things more secure, make things more easy to use, and that's a good thing. So this is okay. It's okay for us to revisit stuff we've had existing for a while. Change is good. We have to rely on this stuff. And it can make, I, as a maintainer, am very happy to see this. It makes my life much, much easier. It can make it easy to, if it builds, it's going to work for the most part. That's a very big hurdle that C doesn't have in places. We make the compiler do the work, and that's the key. We have the tools. Let's rely on those. So it makes Rust more fun for maintainers. And I'm very happy to see that. And it makes it more secure for Linux and for users. And that's more important for you guys. And that's great. And as always, world domination is proceeding perfectly. Thank you.